We keep hearing that we're on the brink of this incredible new age, right? An age powered by artificial intelligence, an age of abundance, of intelligence, just unprecedented progress. But is that what the data's actually telling us? Let's dive in and find out. I mean, just look at this. On one side, you've got AI's capabilities just skyrocketing. I'm talking about things like machine vision, where the error rates have absolutely plummeted, way past what a human can do. But then you look at the other side, global productivity growth. The thing that makes us all better off. It's been slowing down for years. It's just sputtering. So, what gives? How can we have this incredible, almost magical technology on one hand, but we're just not seeing that economic boom you'd expect to go with it? It's a weird situation. In fact, as one paper so perfectly puts it, we're living in an age of paradox. All right, to really get to the bottom of this mystery, we have to dig into these two totally conflicting stories. The story our tech is telling us and the one our economy is telling us. This whole thing has a name, actually, the modern productivity paradox. And I mean, it's easy to see why everyone's so optimistic, right? AI is already matching or straight up beating humans at some really complex stuff. Just take a look at image recognition. The error rates dropped from almost 30% down to under 3% in just a handful of years. That's insane progress. So yeah, of course you have tech leaders talking about an age of abundance and companies with valuations in the trillions. But then you flip the coin, and the economic reality tells a totally different story. Productivity growth here in the US, it's been chopped in half, falling from 2.8% a year to a sluggish 1.3%. And for most people, real income has basically flatlined. This all feels eerily familiar. It's like we're back in the 80s with the old solo paradox. We see computers everywhere, but in the productivity statistics. So that brings us right to the heart of it, the core question we're trying to answer here. Why is there such a massive disconnect? Are all the tech optimists just wrong? Or is there something else going on here, something deeper, just beneath the surface? Okay, so let's put on our detective hats. Researchers have come up with 4 main explanations for this whole paradox, and you can think of them like clues in a mystery, and all of them are pointing to one main suspect. So what are the clues? Well, first, there's the idea that the hype is just, well, hype. It's all false hope. Second, maybe we're just not measuring the economy correctly. The benefits are there, but our stats can't see them. Third, maybe the gains are totally real, but they're only going to a tiny select group of people. And then there's number 4, and this is the one you really want to pay attention to, the idea that we're stuck in a massive implementation lag. And, just like in any good mystery, all the evidence starts to point in one direction. And the most likely culprit here, the main reason for this paradox, is that it just takes a really, really long time for us to figure out how to actually use these profoundly new technologies to their full potential. And that's because AI isn't just, another gadget. It's what economists call a general-purpose technology, or a GPT. Think of things like the steam engine or electricity. Their real power wasn't just the invention itself. It was how they forced us to reinvent everything else. Factories, cities, our entire way of life. And that process, it doesn't happen overnight. It takes decades. And this brings us to such a critical point. There's this fantastic quote that says, "Never mistake a clear view for a short distance." We can all see the incredible potential of AI out there on the horizon, but getting from here to there, well, that's a very, very long road. Okay, so to really grasp just how big this challenge is, we need to pop the hood and look at the engine of AI itself. We have to understand the fundamental thing that's been driving all this progress. And it's a principle with a great name, the bitter lesson. So, how does AI really advance? What makes these modern systems so incredibly powerful? What's the secret sauce that let them just leapfrog decades of slower, more incremental progress? Well, AI pioneer Rich Sutton absolutely nailed it. He said that the biggest lesson from 70 years of AI research is that general methods that just leverage computation, basically brute force, are ultimately the most effective. And not just by a little, but by a huge margin. The key isn't about programming clever human insights, it's about throwing raw, massive computational power at the problem. So you have these two totally different ways of thinking about it. For decades, the old approach was to try and meticulously code human expertise into a machine, like all the rules of chess. And that worked, kind of, for a while, but it always hit a wall. The new approach, the one that's winning, It just throws all that out the window. It uses general algorithms and just immense amounts of search and computation. It doesn't get stuck, it just scales up with more computing power and, well, it ultimately wins. And that is the bitter lesson. The incredible progress we saw at the very beginning, those plummeting error rates, it's not because we had some elegant breakthrough in understanding intelligence. Nope. It's the result of this brute force computational approach, running on a scale that was unimaginable until recently. But there's a catch. A big one. Leveraging computation on that kind of mind-boggling scale comes with a very real physical cost. A cost that might just be the single biggest bottleneck preventing us from reaching that promised age of abundance. We have to talk about the energy footprint. And this is the trade-off, plain and simple. If you want the computational power that makes AI so incredibly effective, you have to be willing to use a truly massive amount of energy. There's no way around it. Okay, let's make this real. Think about a simple Google search, something you do all the time. Right now, that uses about 0.3 watt-hours of power. Not much, right? But what if you power that search with one of these new, powerful AI models? Well, that same search could suddenly use almost 3 watt-hours. That's a 10 times increase for one search. Okay, now let's scale that up. Imagine if every Google search used that new AI tech. The total electricity consumption for Google alone would be about 29.3 terawatt-hours a year. To put that in perspective, that is more than the entire country of Ireland uses in a year. And that's just for Google searches. Wow. So this brings us to the final, and maybe the most critical piece of our puzzle. The future of AI isn't just about writing smarter code. It's a hardware problem. It's an energy problem. It's all about finding a balance between progress and power. And make no mistake, the demand for this power is about to explode. Right now, yeah, there are some supply bottlenecks with chips, but by 2027, a company like NVIDIA could be shipping 1.5 million AI servers every year. The potential energy they'd consume 134 terawatt-hours annually. That number is just staggering. But here's where it gets really tricky. You might think, okay, we'll just make AI more energy efficient. But that might not solve the problem. In fact, it could make things worse. There's this old economic idea called Jevons paradox, and it says that when a technology gets more efficient, it also gets cheaper. So we end up using a lot more of it. So more efficient AI could lead to total energy use going up, not down. And that leaves us right here with this one big final thought. The grand promise of AI is that age of abundance. It's the potential solution to that productivity paradox we started with. But unlocking that future, well, it comes with a really steep energy bill. So I guess the ultimate question isn't whether AI can deliver on its promise, it's whether we can actually afford to pay the price.